Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2126, indicates an issue with the APP sensor B, also known as TP sensor E, which is effectively a throttle position sensor used in your Honda Pilot model year 2016 to 2022. This fault arises when the signal levels from this sensor fall outside predefined thresholds. The APP sensor plays a crucial role in controlling engine performance by relaying the position of the accelerator pedal to the engine control module, ECM, typically located on the accelerator pedal assembly. If the sensor cannot provide accurate voltage signals, it can lead to performance issues or even unsafe driving conditions. In this guide, we'll explore the causes, symptoms, and troubleshooting steps necessary for diagnosing the P2126 error code effectively. The P2126 error code signifies a malfunction in the APP sensor B, which is integral in determining the throttle position based on accelerator pedal input. This sensor directly influences engine behavior and is crucial for accurately adjusting fuel injection and throttle response. The APP sensor is situated in the accelerator pedal assembly, enabling it to sense the degree of pedal depression. This information is transmitted to the engine control module, ECM, which calculates the necessary adjustments for optimal engine performance. When the APP sensor reports voltage signals that fall outside the expected range, typically below 0.19 volts or above 2.62 volts, it causes the P2126 code to be set, indicating a malfunction in the sensor or its circuits. When diagnosing the P2126 DTC, several potential causes should be considered. A faulty APP sensor is the most straightforward explanation, as it can fail and provide incorrect readings to the PCM, powertrain control module. Wiring issues, such as damaged wires or shorts, can significantly affect voltage signals, leading to code generation. Additionally, loose connections at the sensor or wiring harness can result in intermittent issues where the conditions may not be consistent. Another underlying factor could involve the PCM itself, which may not process signals correctly from the APP sensor, though this is less common. Understanding these causes is key to effective troubleshooting. The symptoms associated with DTC P2126 typically manifest through a range of engine performance issues. The most notable symptom would be an inconsistency in throttle response. Drivers may notice a delay or unresponsiveness when pressing the accelerator pedal. This could lead to a frustrating driving experience, especially when attempting to accelerate quickly. Often, drivers may also observe warning lights on the dashboard, such as the check engine light, indicating that the vehicle's ECM has detected a fault. Since the throttle position is intricately linked to engine performance, other symptoms may include a decrease in fuel efficiency or unexpected engine stalling under load. The first step in troubleshooting the P2126 fault is to verify the problem through direct measurements. Begin by turning the vehicle to the on mode, ensuring that all electrical systems are activated. Utilizing the HDS Honda Diagnostics system, monitor the voltage levels from APP sensor B. The current conditions should then be compared against the specified thresholds, where readings should ideally be less than 0.19 volts or higher than 2.62 volts. If the voltage matches these thresholds, you are confirming the fault, leading you to proceed with further diagnostic steps. If no match is found, it indicates the system may currently be operating without faults. Thus, further investigation into wiring connections is needed. If the prior voltage check does not confirm the issue, it's vital to perform a secondary verification step. Once again, Scrutinize the APP sensor B voltage with the HDS in the vehicle's on mode, this time looking for readings exceeding 2.62 volts. If this condition confirms, it indicates a fault that needs to be addressed. However, if the reading indicates normal operation, it could signify an intermittent fault, potentially linked to poor connections or loose terminals. In such cases, inspect the connectors at the APP sensor and the PCM for any signs of damage or looseness. It is beneficial to replicate the conditions in which the DTC was recorded to verify if the issue reoccurs. To investigate possible issues further, the next step is to check the VCC4 power line associated with the APP sensor. Begin by turning the vehicle to the off mode. Following this, disconnect the APP sensor 6P connector to isolate it from the system. After disconnecting, turn the vehicle back to the on mode, but leave the APP sensor disconnected. Measure the voltage between terminal points 1 and 2 on the connector. You should be looking for an approximate voltage of 5.0 volts, which is indicative of proper electrical functionality. If the voltage falls below this threshold, it suggests a potential problem in the circuit that must be addressed. Following the check of the VCC4 line, the next critical step is to assess the integrity of the wire connections. With the vehicle turned to the off mode, use the HDS to jump the SCS system communicating line for more than a minute, allowing for accurate readings. After the wait, disconnect the PCM connector A, 51P, to begin testing. It's now crucial to check for continuity between test points located on the APP sensor 6P connector and body ground. This procedure verifies whether the APP sensor's wiring experiences a short circuit. If continuity is present, it indicates a short in the APS2 wire, requiring repairs. If no continuity is found, the wiring appears intact, requiring you to shift focus to other diagnostic steps. In the continued effort to diagnose the P2126 code, you will need to check for open wires in the APS2 line connection. Begin by connecting terminals A and B of the APP sensor 6P with a jumper wire, grounding it appropriately. The goal is to test for continuity, monitoring whether the electrical signal can pass between designated points while the wiring remains disconnected from the APP sensor. If continuity exists between the points, the wiring is in satisfactory condition and does not require immediate attention. However, if continuity is absent, it points to an open within the APS2 wire, necessitating repairs to restore proper function. As the troubleshooting process advances, it's now important to assess the integrity of the PCM's internal circuitry. First, reconnect the PCM connector A, 51P, and remove any jumper wires from the APP sensor. Then, connect the terminals of the APP sensor's 6P connector to check the performance of APP sensor B by measuring its voltage. Activate the vehicle to the on mode again and validate if the readings from APP sensor B fall below 0.19 volts. If they do, this indicates a continuing fault, suggesting either the need for further consultation of service information or the substitution of a known good PCM for analysis. Conversely, if successful readings are obtained, replacing the accelerator pedal module is warranted. The next step involves verifying potential open wires in the VCC4 line, while ensuring all other checks have been completed. Similar to the previous steps, start with the vehicle turned off and then jump the SCS line for a period exceeding 1 minute. Disconnect the PCM connector A, 51P, for complete system isolation. As part of this step, connect the APP sensor's terminal A to body ground with a jumper wire, effectively allowing continuity testing between necessary points. If continuity is confirmed, this suggests that the VCC4 wire is functioning correctly and prompts a final examination of external sources related to the DTC. However, if results show no continuity, further inspection and repair of the open circuit between the PCM and APP sensor line are necessary. For the next troubleshooting step regarding DTC P2126, you will focus on the APP sensor itself. Start with the vehicle in the off mode and completely disconnect the APP sensor 6P connector. Afterward, switch the vehicle to the on mode and measure the voltage between the specified test points of the connector, verifying that you are receiving around 5.0 volts. If voltage levels are met satisfactorily, this indicates that the APP sensor is potentially faulty and should be replaced. Should the reading be inadequate, further investigation will guide you to check additional systems before arriving at a conclusion. In wrapping up the troubleshooting process for DTC P2126, you will now check for any open wires in the SGND signal ground line. Begin by turning the vehicle to off and jumping the SCS line for stabilization. Disconnect the PCM connector A51P, as earlier steps have shown. Use a jumper wire to connect the APP sensor's number 2 terminal to the body ground for continuity testing. This allows for a final assurance check of the SGND wire's condition. If you are able to confirm continuity, you can once again consider that line free from fault. Should there be a lack of continuity, repairs on the SGND wire are essential to ensure accurate electrical performance. After successfully completing the previous troubleshooting steps, it's crucial to verify that all necessary repairs have been completed effectively. Start by confirming any parts have been correctly installed, especially after replacing components like the APP sensor or PCM. Next, clear the DTCs from the system using the HDS to reset any stored error codes. After that, a test drive of the vehicle is essential to ensure that the issue does not reappear, allowing you to confirm the integrity of the repair work. This final verification step ensures peace of mind for both the technician and vehicle owner, reinforcing that the DTC P2126 has been addressed thoroughly and effectively. To prevent future occurrences of DTC P2126, it's important to engage in routine preventive maintenance of the vehicle's electrical systems, particularly the APP sensor, connector, and wiring harness. Regular inspections should be performed to check for any signs of wear, fraying, or corrosion that might affect conductivity. Additionally, ensure that all connections are tight and secure, avoiding issues related to loose terminals that could lead to intermittent faults. Keeping the software of the PCM updated is also recommended to ensure optimal performance and error handling. These proactive measures will ensure longevity and reliability from your Honda Pilot's performance components. In conclusion, this guide provided a meticulous approach to diagnosing and resolving DTC P2126, ensuring that critical components of the throttle position system were adequately inspected and verified. By following the outlined steps, technicians can systematically identify issues with the APP sensor, wiring, and PCM that contribute to this fault code. Maintaining a clear checklist of symptoms and potential causes aids in efficient diagnostics and issue resolution. Additionally, after repairs are completed, it's advisable to implement preventive maintenance routines to mitigate future issues. Ultimately, applying this structured diagnostic approach to your Honda Pilot from 2016 to 2022 will contribute significantly to its performance and reliability on the road. Please like and subscribe to the channel. See you next time.